This is Gail Kovac for Gresham Barlow School District, Summer School, High School Credit Recovery, Geometry, and Learning Target number 2. I can identify and transform figures through reflection. So we've talked about transformations. It is taking a shape or a figure and it is moving it in some fashion that does not warp the figure. It keeps it congruent to its original. It's just slid around or put in some different position. We just talked about translations, which is like a slide. And now we'll talk about reflections, which is like a flip over a mirror. So in our first problem over here on the left, we have our original figure, which is AGRW in black at the bottom, and our transformed figure, which is A prime, G prime, R prime, W prime at the top in blue. That is our after the reflection. So we want to describe what is the reflection that occurred to go from the before at the bottom to the after upwards. First thing that we need to do is identify the mirror. Where did this figure get flipped over from? So let's see, very often they're going to be either an axis or maybe a diagonal like y equals x or x equals negative y, that kind of thing. Sometimes they'll also be just vertical or horizontal lines like x equals 4 and y equals negative 2, something like that. So what I'm looking to do is map my original point R. Let me look at this one, for example, R to R prime. So R started here and then it went over here. The mirror is going to be halfway in between those 2 points. These 2 points have a distance away of 1, 2, directly vertically. So the halfway point in between them is going to be right here on the x-axis. My prediction is that the mirror is going to be the line of the x-axis here. But I want to double check to make sure that all of those points got reflected over that exact same line. Let's try now W and W prime. So here's W the before and W prime the after. And it looks like those are separated vertically. Let's see how many points. 1, 2, 3, 4, a distance of 4 across. So 2 across would be halfway in between, halfway here and halfway here. And again, my mirror point has landed on the x-axis, so I predict my mirror is going to be the x-axis. Let's just double check all of the other points. If they truly are congruent, they should follow the same format. Let's see here. Let's try G and G prime. It looks like those are just vertically aligned here. And this goes 1, 2, 3, 4, 5, 6, 7. They are 8 across, so 4 down and 4 up. Again, we're on that x-axis right there. And last one, we're going to do A. Here's A and A prime. Again, those are just aligned vertically here, and they are, I believe, 5 across. 1, 2, 3, 4, 5. 1, 2, 3, 4, so 10 across, and again, they land right here on the x-axis. So all of the points have been flipped over points on the x-axis. Therefore, my mirror is the x-axis here. All of my points got flipped an equal distance perpendicularly across this x-axis right here. So this is my mirror. So this is a reflection across the x-axis. So I'm just going to put x-axis right here. That is my mirror. X-axis. Oh, let's spell that correctly. That would be a good idea. X-axis. So that was my mirror, and that is what I am looking for. If it is across the y-axis, then it's going to go horizontally like this. If it is across a diagonal like this, then it's going to get flipped over the line y equals x here. Maybe the line y equals negative x could also be your mirror. You could also have a mirror which is down here at y equals negative 3 perhaps, or maybe y equals 1. You could have a vertical line which is your mirror perhaps at x equals negative 3, maybe x equals negative 1. You could even have it cut through the shape itself, and maybe it's at the x equals 3, something like that, but you're looking for where's the line that divides the connections between the mappings between each point and its after point, its prime point, in half. So in the second problem, we're going to now perform a reflection. We're going to reflect the figure across the y-axis. So in this case, this is going to be my mirror up and down here. And I want to make sure that my prime points lie an equal distance across this mirror from the starting point of my, my quadrilateral ASTJ here. So let's start with point A. Here's point A. Right now, perpendicularly speaking, A is 1, 2, 3 spaces away from my mirror. So I'm going to count an additional 3 spaces, 1, 2, 3, continuing in that line on the other side. So here is A prime. Okay, let's do the same thing here. Let's go to point S. I got to figure out where S prime is going to be. I'm going to travel to my mirror perpendicularly. That's at 90-degree angles. That's straight directly to it, shortest distance. And then I'm going to continue going that same distance on the other side of the mirror. So point S is 1, 2, 3, 4 spaces away from my mirror. I'm going to do another 1, 2, 3, 4 spaces away right here. That's where S prime is going to land. All right, so now let's try point T over here. Where will T prime end up? I'm going to go straight to my mirror perpendicularly. 1, 2, 3, 4, 5 spaces away. Let me do another 5 spaces to get to T prime. 1, 2, 3, 4, 5. It looks like it's going to end up right there on the edge of what I can see of this coordinate point plane. So there's T prime. I got one more to go. So here's J. Let's figure out where J prime is going to land. 1, 2, 3, 4 spaces to my mirror. Keep going, another 4 spaces. 1, 2, 3, 4 spaces to the other side. There's J prime. There's my after. Now what I'm going to do is connect those 4 prime points together and make sure that everything looks correct. So let's see here. 1, 2, 3, 4. So what I want to make sure is that my mirrored image is in fact congruent or a photocopy of my original shape. I want the lengths in between all of the points to be the same. I want so that if I were to reflect it across, it would land back on itself. So let's see. It looks like A and J here, A and J, that looks pretty correct. A and S, yep. If I had a ruler, this would look a lot better, but from S and T, that looks correct. T and J, yeah, everything looks correct. This looks like the same shape, just oriented in a different manner. So just like these two shapes are completely congruent, it's this same shape just moved around. We call that a rigid motion. It doesn't change the shape, it just puts it in a different place. My prime shape does also look congruent to my original, so I think I've done this correctly. If I had J prime down here and these were longer and it looked a little off, I would say, okay, I've plotted a point incorrectly. Your new shape should look identical to the original one, just put in a different place.